Okay, so let's go back to this particular problem with this curve graph, and it's a distance time graph. So let me label this this distance in meters, my y-axis, and then this is time in seconds again. Right, now the problem with these curve graphs is that when I want to work out the speed, before I could only work out the average speed between 2 points. So when I wanted to work out the speed from 3 seconds to 8 seconds, that's okay, I can do that. I can just draw a line between those two and work out the gradients of that line. But the problem is this curve represents an object that's not traveling at a constant speed. Its speed is clearly increasing, right? Because it's getting steeper and steeper. That means as time goes on, this thing is getting faster and faster and faster because the distance is climbing. If it was a straight line, then it would be a constant speed. But my problem is this: if I want to work out the speed, again, I have to pick 2 points on my line and then work out the average speed between them. But what if I actually wanted to know the speed at exactly 3 seconds? I wanted to know what that speed is there at that time, not between two different points. I want to know at 3 seconds, what is that speed? Okay, or maybe I want to know exactly at 3 seconds what that speed is. Now the problem is this: it's curved, right? Now what we could do is, maybe pick another point slightly close to it, like this, okay, and then maybe draw a line between those two, and then you know what, that might be a good estimate for what the speed is at 3 seconds. But if I pick this point, which I've picked at 5 seconds, again, that is still an average speed between these 2 points. So I'll draw my right angle triangle here and work out this vertical step and divide it by the horizontal step. But I'm still working out the average speed. So it's still not what the speed is at exactly 3 seconds. It's the speed between these two times 3 and 5. So what we could do is we could, okay, starting with 3, make a point even closer to it. So maybe even closer, maybe half a second across. So that's 3.5 seconds, and then I could draw a tiny little line, okay, and then work out that tiny little vertical step and that horizontal step and divide them and get the speed. But again, I'm still working out the average speed between two different points on my line. It's still not the speed at exactly 3 seconds. But again, we could go, we could zoom in and maybe make a really tiny triangle here, maybe like 0.1 of a second across, and then see what the vertical and the horizontal step are. I'd have to zoom in on that, and at the moment I can't on this still picture, and it's not on graph paper, that makes it doubly difficult. But if we sort of have that principle that, okay, we pick 2 points but we get closer and closer and closer and closer, and make, join these lines up and work out the gradients of these ever decreasingly small lines, then what we're actually approaching is a tangent, okay, a tangent line. So if I want to work, I'll have to estimate it because I'm doing it by eye. But if I want to work out the speed at exactly 3 seconds, I would have to draw a tangent line at 3 seconds. Now let me try my best to do that. I'm doing it by eye, so it makes it a little bit difficult. So let me do it in red. So I need to draw a tangent line. If you can remember what a tangent line is, if you have a curve like this, a tangent line is a line, let me pick a point, that just touches the curve like that, okay? I mean, that's not great because there's a little gap there, but it just touches that point that I picked on that red line. So let me try and do it here with this particular point. So I have to try my best with this. Let's see if I can. Alright, that's not great because try and get the gap either side. It would be better if I had maybe a ruler and some graph paper. If I was doing this on a piece of paper, it would actually be a lot easier than doing it on the computer. Let me try it again. Okay, that's a bit better. We'll just have to accept that for now. It's not great. It's actually quite hard to do it on the computer, but try and get the gaps either side if you're doing this for homework or something like that. The tangent line. Try and get it so that gap is roughly equal to that side. Right. So there's my tangent line, and what I want to do is work out now the gradient of this tangent line, and I've got the speed at 3 seconds. So if I draw my triangle, if I pick 2 points on my on this line that I've just drawn, I could draw it however long I want actually, but let me actually, you know what, let me make it a little bit bigger. So let me do it in red. So let me make it a bit bigger. So let me hold, oops, okay, let me do it again. So holding down shift button and then like this. Alright, and then go back the other way. Okay, so I'm making it a little bit bigger. Right, let's see. Okay, that's actually pretty big, and we'll get some good readings off on this. Right, so let's see. Let's make a triangle out of this. Let's pick 2 nice easy points. It looks like it goes through 0. I'm only estimating. So go across and up. Let's see, this is a good point here. Right, let's see what we got here. Right, the horizontal step is from 0 to 8, so that's 8 seconds. And then again, I'm sort of guessing here. It's not done on graph paper, so I can't really do it accurately. But all right, that's roughly 8 seconds. And the vertical step is, let's see, from the very bottom to the very top is 50 meters. Right, so if I want to work out this speed at 3 seconds, an estimate for it, using the gradient of this tangent line at that particular point would be 50 divided by 8. Okay, so 50 divided by 8 is 6.25 meters per second. Okay, so that's what we can say is an estimate. So I really should put roughly equal to the speed at exactly 3 seconds rather than between 2 points. We've sort of estimated the speed, sorry, at 3 seconds. But okay, well, let's actually go to the computer and the GeoGebra software, and let's get the computer to do it accurately for us, right? And let's get the exact answer and see how far off I am from the actual speed at 3 seconds. So here's my graph, okay? And let me plot a point at 3 seconds. So let me do that. All right, okay, so that's on 3 seconds there. Now what I want to draw is, well, I'm going to get the computer to do, so I don't want it to label any new objects. I'm going to get it to draw an accurate tangent line. It's going to draw the exact tangent line, right? Not my sort of rough rubbish one. It's going to draw the exact one. Okay, so let me remind myself how to do that actually. It is one of them. It's tangent, right? Okay, so click on the dot, click on the curve, and there you go. There's your tangent line. Now let me just right click on this line and get it to show the label of it. No, not show the label. I want it to let me see, object property, show the value. Alright, okay, let me see if if I can just adjust this. If I can click that. No, I can't move it. Alright, let me see if I can move across then. Right. There we go. Right. Let me move it. Oops, it keeps moving around. Right, over here in the corner. Damn it, stop moving. Right, it's got the equation of this tangent line, the y equals mx plus c of this tangent line. And it's got y equals 6.6x plus 0.21. Well, the gradient of this line is 6.6 down in this corner here. You can see, y equals mx plus c. 6.6 is the gradient of this tangent line. And, well, we got 6.25, and the actual gradient is 6.6, so that'll be the speed as well. Remember, the gradient of the line represents the speed here as well. So 6.6 meters per second. It's not too far off. It's not too far off this answer here. There's 6.25. But the problem is this: when you're drawing tangent lines, you're doing it by eye. So what we need to do now is to find a method that allows us to work out exact answers like this, 6.6, using algebra, and that's what we're going to look at next. Okay, so we're going to use algebra to do that for us. Okay, so that's the next step. So we looked at tangents. This is sort of this one that we've done by eye is sort of an estimate of the speed at exactly 3 seconds. The computer told us exactly what the gradient is at 3 seconds is 6.6. But the next clip is going to talk a little bit about how we can do this algebraically and get the exact answer instead of a rough estimate, yeah? And instead of doing it by eye, getting an exact answer like this one here. Okay, so see you in the next clip.